Otherwise, you just need to, nearby the connector, apply a termination resistor. So the way CAN bus works is you're supposed to have, on each end of the bus, you're supposed to have I think a 120 ohm termination resistor.
Do you know why we use CAN on vehicles?
No.
I don't either.
Oh.
I worked at Toyota for 3 years. For a year and a half of those, I was programming the computer, and
I mean, it is a bus, which unlike SPI, right? SPI is essentially point-to-point communications. So it's a bus, you can connect a number of devices to it. It's got, in it has some, like error recovery and redundancy. So there's detection and correction for errors built into it.
yeah, it actually.
And it allows addressing to a number of different devices, right? So you can uniquely identify and address a number of devices on the bus. I guess other than say it was designed for cars.
Maybe was it? Okay, that makes sense. No,
That's probably no.
I think it has to do with it's robust to hardware failure, or it.
Inexpansible and reasonably fast enough. They have newer versions that are faster. So this is a regular CAN. There's also CAN FD and some newer controllers and some other things. We've started to see people putting Ethernet in cars or like long SerDes connections for video cameras. So it's not the only bus seen in cars.
There's some new ones too that use a little bit of fiber optic as well. For some strange reason, they're using fiber.
That sounds like it's prepping for the future.
Yeah, there's a whole thing like what is OBD2 and what are all the different interfaces on there, because there's other networks on there besides just CAN on that. The other thing to point out here is librobot control, right? Which is really that's the magic thing. That's the software bit that allows you to control all these different interfaces. So all the stuff that's kind of assumed outside of the Beaglebone Black wireless. A couple other headers. There's a power header and an analog header on here as well. So there's a 1.8 volt analog. Long history there, but it's essentially the A to D converter on the chip is a touchscreen controller. So it's actually bidirectional. It was taken from a mobile phone, so that's why it's low voltage. It's taken from a mobile phone chip. But the signals are actually bidirectional. They're not just A to Ds. You actually, if you're doing a touch panel, you essentially assert one side high and then measure the resistance, and then assert the other one high and measure the voltage in order to determine the resistance. Just figure out where you're touching in an XY region. So it has that capability on that. So you could potentially use those 4 wires to do a touchscreen. 4-wire touchscreen. So part of the magic, though, that all this kind of comes together, and what we're going to experience next when we're going to flash these guys. Let's stop here. At this point, who has their SD card programmed? Okay, we're going to use theirs, right? So we're going to go ahead and insert the SD card into the board. They're all powered off at this point, right?
I just rip it out.
So.
Did you say we should safely eject it?
Oh, I didn't know there was one already inserted. If you have one inserted, eject it.
He's talking about it from his PC.
Oh, from your PC? No, it doesn't matter. After it's flashed, it doesn't matter if you safely eject. They shouldn't be mounted on the. I guess if you have a Linux system, they might mount. But I guess there's also a fat. Is there a fat partition on there? I don't think there's a fat partition on these SD card images, so they shouldn't even mount on a Windows machine or a Mac. They would only really mount usefully on Windows. Anyway, safely ejecting shouldn't be a requirement. The SD card position is, so it's on the bottom side, and the top goes the same direction as the board. So it orients to the top, goes along with the board. It won't go in nicely the other way, don't force it. This is a push-push connection, right? So you push it in, it should give you that nice little satisfying little
And don't put it
push,
on
and then
your
it comes back just a tiny bit and stays there. So if that's not what you experience, then something's wrong.
My encoder wires are a little hairy. Should I fix that before I power it on?
We'll fix that at some point, because I think some of them don't have the motors plugged in and some other things, so
Well, I
we'll
mean,
kind of go around
we
and
could have
straighten all that stuff out. But
It looks like the encoder wires are shorted, but that won't hurt anything, right?
there's power and ground that goes to the encoder, so if power and ground are shorted, that would hurt.
Looks like we got ground and the white ones are shorted. The black one's okay.
Really?
Well, they have little frayed ends that are crossing, and it's hard to. We don't have any more of these, do we?
No.
Okay. I'll get a little tool and clear it.
I guess a little paranoia goes a long way. Yeah, you don't want to have power and ground connected. Does anybody who has a USB cable? Are there 5 USB cables? Because we can power it off with the battery, but I think for flashing we're just going to be just fine powering it off with the USB cable. So.
Daniel, do you need one?
Yes. I'm going to add a little bit on the power section of the board into the slots here.
Don't burn it. Oh, there's it.
Okay, yeah, then you can connect this to your computer.
I gotta check some power. I recognize that.
Select it on there.
Just an experiment.
It's an old board. I think I tried to add the LED. I might have tried to add the LED to that.
Did that back?
Yeah, it's fine. Yeah, I added that to power off to power.
Is that backing right now?
Okay, but it's not.
It was working.
I didn't power it up yet.
But yeah, I was doing experimentation. I don't even remember what I was doing with that.
We're not using the battery. We're using this.
I would if we could just use the USB cable for this. I was going to go and talking about that just to say why, go over the power section, but for flashing, USB power is all we need. That's the short answer.
What are you missing? USB cable.
We don't have one that can use one.
Yeah, we plug it in. Here's the legs. Yeah. Hey David, do we have any extra USB cables?
Yes.
So the group at the end does not have.
We have all of our just
I can lend that.
I'm not sure if I need to make a new diagram to kind of show this the best. But what
David.
Who needs
VBAT is used for essentially like this stuff, like the servos and the DC motor drivers, right? That's powered by the battery. But this section on here, essentially the Beaglebone Black Wireless, is powered by the USB or battery. So that's the part of the drawing I want to show. This one right here.
I don't see any USB cables.
Are we still missing one, or do we still need one?
No, I think everyone has one now.
Everyone has one.
Do you have them?
You gotta keep up, man.
Everyone has one, so let's
We did, but then we found them in our.
don't plug it in yet, but
No, I already did.
all right, go ahead and plug it in now. Did you, when you plugged it in, did you hold the SD card button?
Nope.
No.
So if it started flashing, then it was a new enough bootloader on the flash already. The boot process is by default it tries to boot off of the onboard flash first. Right, so it's going to try to boot from the onboard flash before it tries to boot from the micro SD. Now, the bootloader on the onboard flash will typically look for an image on the SD card and then try to boot it off the SD card.
And the bootloader is
But if the
prepared-
bootloader on the flash is too old, it won't be able to. The bootloader.
I want to make a clear definition of a bootloader.
Yeah.
I'll tell you what I think it is, and then you can fix my definition. I think it's the first set of instructions that the computer looks for to execute when it receives power. And in this case, when you said it directs you to boot from the SD card, that means it's pointing to the next set of instructions to come from the SD card.
That is a really good explanation. I wonder if everybody got it.
It's hard to get just a single definition online.
Yeah, so on the ROM, so they're on the chip itself, the instructions that it begins executing at power up is there's essentially this ROM, so read-only memory. So this never changes. This is in the silicon. You can't accidentally overwrite this. The only way you can damage this is by sending voltages through the board and running it through a shredder. It is hard coded in the chip itself. You can't screw up the ROM. Okay, you can fry the board, but you can't screw up the ROM. At power assertion, there are these things called the sysboot pins. So those are I/O pins on the processor itself. They're sampled one time, and that's when you apply power. A few milliseconds after you apply power, they're already sampled. It's probably in the order of about 10-15 milliseconds in that ballpark. Changing them afterwards won't make a difference. It's latched them in, it's decided what it's going to do, and it's going to do it. If you do a reset on the board, it's going to say, hey, the sysboot pins when I powered up were this. So guess what? It's going to repeat exactly what it did before. It doesn't sample the sysboot pins again. It only samples them upon applying power. Good. So based on those sysboot pins, it's going to decide this thing about where it's going to find a bootloader. So it's running a bootloader, but we're going to run another bootloader and then another bootloader. So a bootloader is just a piece of code whose job it is to get other code to run. It's going to load code in order to to run it, right? And that's its whole purpose in life. So there's the ROM bootloader, decides what it's going to do based on the sysboot pins. If that SD card button that's down here, it's the one away from the other 4 buttons. It's the one that's down close to the servo header. If that button is pressed, it's going to change the sysboot pins. It's going to change the boot order. So it's going to try to look, instead of the eMMC flash first, it's going to look at the microSD card first. If you want to make sure that you have a very predictable experience based on the microSD card,